So this is Kalya Murugesan from ZSL. Welcome for the webinar, Cloud Computing, Use Cases and Best Practices. The speaker for today's session is Naveen Noel, Senior Enterprise Solution Architect, Idea Lab, the R&D division of ZSL. Naveen will discuss on the best practices and guidelines involved in creating cloud-based IT environment and key features of cloud computing and how to identify cloud computing needs. During the presentation, all participants will be muted. You can submit your questions on the right-hand side of your screen using the chat window. We will answer some of the questions during the Q&A session that will follow the presentation and answer any remaining questions offline. Today's presentation will be recorded and posted to the ZSL's TV and webinar page. With that, I would like to turn the presentation over to Naveen. Welcome, Naveen.
Yeah, good morning, good afternoon, good evening, everybody. This is Naveen Noel. I'm a Senior Solutions Architect in ZSL. Today we'll be discussing about the cloud computing use cases and some best practices. So let's start. Okay, this session objectives basically, we'll be just giving you a very brief introduction about the company, and probably we'll explore a clear definition for cloud computing, and then we'll go on to discuss some cloud computing benefits and some best practices. So after that, we'll find out how to identify cloud needs. Okay, so we discussed about the best practices, so what are the needs? How do we identify needs? And at the last, we'll share some 6 to 8 case studies of cloud computing. So my role at ZSL, I work out of Edison, New Jersey. I'm a practice lead of the Enterprise Computing Competency at the Idea Lab, which stands for Innovative Development for Enterprise Applications. So basically, my role is to handle the cloud computing competency, and the application side, not much on the infrastructure side. So I take care of pre-sales and projects, and I bring in new clients, engage clients. That's my kind of role. And my key focus areas are basically value-added R&D, which is a part of the Idea Lab, product development, and product engineering. I've been working on the cloud computing technology since the early 2007. So since Amazon came out, a year after Amazon came out, approximately, we started working on cloud computing and exploring different technologies in that area. So the company overview. Very quickly, we glance through this. We are a 15-plus-year-old global technology integrator and a business solutions provider headquartered in New Jersey, Edison. We have state-of-the-art technology research and R&D centers in the U.S., Canada, India. We have more than 4,000 employees all across the world, right from U.S., U.K., Germany, Malaysia, Singapore, Canada, and we have our major offshore development center in India. So we have a dedicated research and development division to offer all this value-added R&D, product engineering practices, all these things. We have a dedicated R&D division. So we work on emerging technologies, specialization with leading vendors like IBM, Microsoft, Oracle, so even the open source also we do it with. We are the pioneers in industry solutions development. We have worked on the insurance, finance, e-governance, consumer electronics, pharmaceutical, telecom. These are the main sectors we work under. So we also have award-winning partnership programs like the Get IT Together partnership. We can always discuss this in some other session, but we do have these kind of programs available. And the last is basically we are ISO and CMM certified solution provider. So we follow quality standards. So let's go into cloud computing. What is cloud computing? There are so many definitions available out in the World Wide Web. If you go to Wiki, go to Google and type what is cloud computing, you'll get a lot of definitions. But let us see what the National NIST says, the National Institutes of Standard and Technology. They say cloud computing is a model for enabling convenient on-demand network access to a shared pool of configurable computing resources. Example, networks, servers, storage, applications, and services that can be rapidly provisioned and released with minimal management effort or service provider interaction. Okay, sounds a bit complex. Let's see what, in a single line, what does it mean? In simple words, it means flexible hosted resource pools delivered on the internet. So as we go further in this presentation, it will be more clearer what the cloud computing definition is. So let's go to the next thing. So what are the essential characteristics of a cloud computing model? So the first one is on-demand self-service. So you have ready-to-use services. You don't have much interaction from the service provider. So you're able to do everything by your own. So that basically is one of the characteristics of cloud computing. Broader network access. You have wider access to network services. As you know, in a typical IT environment, you have limited access. On the cloud, it's the whole network is given to you. You can actually work in that space. So you have a lot of resources, a lot of bandwidth. You can just use what you want. So you have a lot of access there. Resource pooling. We pool resources on demand, like compute, memory, storage, disk. We just get what we need. So we need computing power, we get computing power. We need memory, we say, okay, I want 2 GB memory, and I want, say, a quad-core processor, and I want, say, 2 TB storage space. So I just get them together, go to the cloud, and say, give me 4 processors, give me, say, 8 GB of RAM, and say I want 2 terabytes of memory. And yes, that's it. You get it within a few minutes. In fact, few seconds, you get all these resources pooled together. That is a major advantage. Imagine doing it in a traditional IT environment, what would happen? If you were to say, I want 8 GB of RAM and 4 processors and say 2 TB of memory, it will take days. So that's one of the reasons why cloud computing is becoming very popular. Rapid elasticity, scale up and down, in and out with demand. So what does this mean? So scale up, you can scale your systems up, like increase your memory from 4 GB to 8 GB to 12 GB, increase your processors from 2 processors to 4 processors. That's what we do in scaling up and scaling down. Scaling out and scaling in, we can add a cluster of services, you can add multiple computers together, so and say that this is what my scaling is, add a load balancer on the front. So all these scaling up, scaling down, it can be done in just a few minutes because it's on demand, everything is available. So next is the metered service. Metered usage and billing. Pay as you go only and for what is used. Basically OPEX versus CAPEX. Everybody knows what is this, so I don't have to explain it. So you only pay for what you use. You don't invest in anything and you don't say, okay, I invest a few dollars and I don't know whether I'm going to use it or not. So in cloud computing, you only pay for what you use. So that's one of the major benefits or characteristics. The last one is basically usually share the applications over the cloud, but not always. So basically what I'm talking about is a SaaS-based model. So we'll discuss this in the coming slides. So the last benefit is multi-tenants, where everything is hosted on the service provider and users, where we're basically able to share applications and applications across them. They don't have to worry about anything. So next slide. What are the different service models in the cloud? Now we all know that we all heard these terms: infrastructure as a service, platform as a service, software as a service. We all know these terms are very popular, so I don't want to go too deep into that. But basically, infrastructure as a service deals more with server, with the OS, the network, the storage, and related resources as a scalable service. These resources are provided as services over the web, where users and clients can consume them. So who are the target? They are the ISVs, developers, IT organizations, CIOs, line of business customers. So all of them are targets for this. So basically any cloud computing initiative has to go through infrastructure as a service. So although you see companies like Salesforce, which offers more of a platform and software as a service models, they have to have an infrastructure as a service model lower than that. So the examples of IaaS providers, the biggest one is Amazon out there. It's Elastic Compute Cloud, which is very popular. It's been the oldest, some of the oldest guys in the market here. We also have Rackspace, GoGrid, Savis, OpSource, all these guys. All of them, they provide infrastructure compute services. Basically, you can go and tell them, I want this much of memory, RAM, storage, bandwidth. You just specify your need, and they give you the infrastructure as a whole. So now when you have the infrastructure with you, everything with you, now you need to use that and do what you want with it. So infrastructure as a service ends there. Once they give you all these resources on demand, that's it. That stops there. Then you have to manage everything. Platform as a service, middleware services like applications, databases, application frameworks. So all these kind of services offered are basically the platform as a service. One typical example is the Google App Engine. Azure Force.com's platform, the Amazon's relational database service, kind of a platform as a service. So what they do is they provide you services. Like, for example, Google App Engine provides you a service where you can write, script out applications in Java and Python and many other languages, and you can actually scale on demand when you want. So they offer you a whole bunch of features. But the platform as a service, one thing we have to remember is when we write something for the platform as a service model, there is a specific way we write it. Basically, the applications are locked with that specific vendor. What I mean is, if you take an application from Google App Engine, write it specific to the App Engine platform, you cannot just take it onto the Azure platform and run it there. So each of these platforms have a specific model in which they develop these applications. So we need to be very careful when we choose the platform as a service vendor. A simple example, like if you take the Google App Engine, Azure, Force, or Amazon, say you want to have database access. So there will be different ways in which they do it. So we need to be very, very careful when we choose them. Once we choose them, we have to be locked into them. So we have to be, So the third is the software as a service model, where the whole services and applications are served from the internet. The targets are usually end users. So basically, end users come up, they have a portal, they log into the portal, and they basically work with the portal, and they do everything what they want. They can customize their own website, add their own widgets, and just play around with the entire thing, have their entire application loaded up. Like you'll see some typical examples, like we have been working with software as a service from long way back. If you check all these emails, Yahoo, Hotmail, they're all platform software as a service models. So basically, you go in, you register, you log in, and you have your whole email service with you. That's exactly a software as a service. So that basically runs with a platform. There's some platform which runs. For example, Hotmail is the software as a service model. It runs with some platform at the back. For example, Google Docs also. So you go in, you are able to create PowerPoint presentations, do your documents, anything, whatever you want there. So that runs on a Google platform service. So basically, it runs on the Google platform service, and that is supported by some infrastructure as a service of Google. So Salesforce.com, similar to that, and Constant Contact also. All these services, what you see, they basically reduce, basically most of it, maybe 99.99% they remove any interaction with hardware or any software or any configurations. It's all user-driven. So let's go to the next slide, that is the types of cloud deployments. Okay, we have seen the cloud computing, some characteristics. We have seen different platforms, the different services, basically infrastructure as a service, platform as a service, software as a service. Now let's see what kind of deployments are there. So we hear these terms: public cloud, private cloud, hybrid cloud, community cloud, resource cloud, and they keep on going on. Yeah. But let's stop there. Let's hang on. So what's public cloud? The three clouds you usually will come across is the public, the private, and the hybrid. Now the community cloud is picking up, but I'll explain to you in a few minutes what it means. The public cloud, as it says, external premises, multi-tenant, self-provisioned, public service over the internet offered by the vendor, available to all, utility computing model. Basically what it means is some cloud existing on a third-party data center. So example is Amazon. Amazon is a public cloud provider. So they provide you all these services on the Amazon's infrastructure. So you want to go and basically rent, not buy, sorry. When you want to rent out any services from Amazon, you go to Amazon and say, I want this computing, this compute power, this RAM, this storage, bandwidth, everything you specify, and they'll rent it out to you. So they're available on the Amazon infrastructure. You do not own the infrastructure. You don't know where it is, basically. You don't know where your instance or something is loaded up. Private cloud. Basically, it's internal or an external premises. It's single tenant, tightly controlled access. So there's a lot of confusion between the private cloud, hybrid, and the public. And in fact, when I went to the Cloud Computing Expo also, there was a lot of debate going on the private cloud. So from what I gathered, basically private cloud is basically concise to your IT environment. So you can, basically private cloud is a piece of software. We all know that the public cloud is a piece of software they deploy over a data center. And that's how they're able to do all this computing demands and all that. So private cloud is internal. So you take that same piece of software and you load it in your organization on your hardware. or you can go to a third-party data center and load that software on their data center, but the hardware belongs to you. So it's very clear. In the private cloud, the hardware, you own the hardware. And the cloud software, you can use multiple cloud softwares like VMware is there. You can use Ubuntu Enterprise Cloud. You have got cloud.com's, CloudStack. So although so many of them are there. So you can choose whichever software you want and create a cloud inside your organization or in your data center. But please be clear, you have to maintain that hardware. So the cloud runs on that hardware. So you have to maintain the hardware. You have to scale up, scale down, add boxes, add RAM, memory, computing power. You need to add all that. You've got to take care of it. And that is the private cloud. It's exactly similar to the public cloud. But the public cloud, you do not own the hardware, so you don't have to worry about it. But in private cloud, you own the hardware. Now, hybrid cloud. Hybrid cloud is a combination of the above two, some resource private, some resources are public. So what it means is in every organization, you will definitely come across services which are, some of them are public facing, some of them are private facing. So what the industry is coined a word called as a hybrid cloud. So there's nothing like some cloud being totally public or totally private. So this hybrid cloud concept is picking up. So what you will do is you will create a private cloud. You will also have a public cloud on some public cloud provider like Amazon or something, and you link the two clouds up. Or you can take the same private cloud, expose services, public services, and keep some of the services private. So it's a combination of these two. So some private and some public. The community cloud, a cloud infrastructure, is shared by similar organizations for mutual benefits. It's very popular in universities and governments where they create 2-3 clouds and they basically communicate through those clouds. So you can create this cloud in a public place or in a private place, but necessarily the clouds communicate and different companies come up there, different universities come up there, and they start collaborating or they start using the cloud services. So it's again, it's one of the strains of the public and the private. The public and private are the two main clouds what you will see. So the cloud taxonomy. This is what I was actually wanting to share. This slide was very interesting when I saw it on one of the webinars. So I modified it a bit. So in traditional IT, you see the applications data, runtime, middleware, OS, virtualization, servers, storage, and networking. So these are all required in basically any IT. Now, you have infrastructure as a service, platform as a service, software as a service. It's very clearly explained. In infrastructure as a service, IaaS, you manage the OS, the middleware, runtime, data, and applications as I explained it to you. So you don't have to worry more about virtualization and servers and storage, networking, hardware, anything it's not your concern. The cloud provider, the vendors actually do that. In platform as a service, you still do away with the runtime, the middleware, and the OS. So you don't worry about the OS, the middleware application servers, how they scale, how they manage your load. You don't have to worry about anything. And the runtime also. You are only worried about your data, your applications. So you put your data, put your applications, you get the whole other suite from the vendor. So, excuse me. Then the software as a service. In software as a service, as I said, it's mostly user dependent. Mostly users use it. So right from the networking, right up to the applications, everything is controlled by the vendor itself. So Google Docs example, I am taking a simple example because we use it a lot. So you do not know what networking they use. Neither do you know any of these items displayed there. You don't even know the data, the runtime applications. You don't know anything what they do. All you're concerned is about using that service. And of course, you have the service uses, because you're a user, data is confined to you. So that data which you use will be stored into your own private, into your secure folder, basically. Everything else is controlled by the vendor. So you don't even have to worry about scalability or availability, any of these things. Identifying cloud computing needs. I just quickly prepared the slide, I was just thinking last evening about how do we identify these cloud needs. I came up with a few of them. You can always use it as a starting reference. You can always extend it and keep moving forward and add some more points there to it. I was very, very informal and I wrote this specific slide. So performance. You're having performance issues, So basically, what I'm trying to talk over here is what are the typical candidates for cloud computing. So many of our clients, our prospects, they do not know whether we really need to go for cloud computing or whether I'm a candidate for cloud computing. Just because everybody hears cloud computing, okay, I also want to go for cloud computing. But you might not be a right candidate for that. So how do you identify these needs? So the first one is performance. The client is having performance issues. I'm having performance issues. My website portals are slow. My desktop is slow. Whatever. It's very slow. I want to scale up. I need more power. So that's one point. Provisioning. I'm not able to provision resources quickly. Too dependent on IT. I want 4 GB of RAM. The IT guys say, oh, please put a ticket and wait for another 3-4 days. And when the ticket gets resolved, it comes, and we look into it. We have to buy it, procure it, buy it, raise an invoice first, buy it, and it comes into the organization. When I install it, this takes at least a week. This is the issue which many customers face. Resource utilization. Not utilizing resources completely. I have 10 servers or 50 servers running there. I use only 20 of them, or probably use all 50, but only to 30 or 40% efficiency. So I have a 16 gig machine running there, but I only use 4 gigs. I have like 8 processors running there, but I only use like 2 processors power, only 10% of usage. So this is the resource utilization. So not utilizing resources completely. Resources are idle most of the time. Network bandwidth, a big bottleneck. Somebody downloads something or something happens in the data center and you have a bottleneck there. So how do you scale up? So some organizations put some of their servers inside the organization sometimes. So you have to have a dedicated line for that to run specific websites, specific services. But in the cloud, all this problem is not there. So you just put it on the cloud and they take care of everything for you. So network bandwidth becomes a big bottleneck for some. Testing. This is one of the major use cases or major needs. You need to test on multiple operating systems, simulate through load tests, stress tests. I want to load, say, 500 systems and check how it works. I want to check 500 users and check how it works. Okay, I want to scale up and see what is the metrics for that. So testing becomes one popular use case for cloud computing. I can roll in multiple operating systems, multiple versions of the operating system, and scale up, scale down, and users can start testing it. And something goes wrong, we just shut down the instance and recreate it from the master copy. So it's pretty simple to do that. And you can't measure utilization of resources, as I think I mentioned this point. You don't know how much you've spent versus how much you're actually utilizing. So this is a big problem for many IT organizations. They don't know how much they're actually utilizing, but they spent a lot of money. So again, CapEx versus OpEx, the same kind of concept. So the growing infrastructure demands are rising too quickly. You can't keep up, and servers are being requested, and you don't know whether it's really being used, or all these problems. So this is one of the major things we see from our prospects, that growing infrastructure demands is one of the cloud computing needs. So this is just an initial list. We can always increase this list and make a list, makes us more exhaustive. This is the starting point. Let's discuss some few best practices for cloud computing. So I just try to put it very simple and not make it very complex. So the first is know your need. See if you qualify for the move to the cloud. Engage experts who know this well. So it's actually referring to my previous slide. So that's how you identify the need. So be sure you know you're a candidate for cloud computing, and cloud computing will solve your problem. If you do not know, engage experts who can actually educate you about this, and they can tell you, okay, fine, cloud computing will solve the problem, and what kind of cloud will actually solve your problem. Provider. Identify the right type of cloud provider, IaaS, PaaS, and SaaS. Choose your provider, Amazon, GoGrid, Rackspace, OpSource. They are similar kind of cloud providers. I just gave some few examples, but they're a little different the way they work. The pricing models are a little different. So that's one thing. Make sure you choose the right provider. Licensing. Check your product's license model. Some do not yet offer the subscription model. So we just take to the cloud and put it up on the cloud. Okay, I want to move to the cloud, and then I have some kind of a software or product which runs on in my organization. I want to move that to the cloud, but some of the vendors, they do not provide cloud-based license models. So please check with your vendors, check your license models of your products which you use. Metering and billing. Make sure you understand the metering and billing correctly. So they talk in cents. So they talk in cents when they talk about consumptions. So make sure you get a clear understanding of what you're being billed for and what are you being metered for and what are you being billed for. Do your calculations the first time. First couple of months, do it, find out, and see whether you're nearing, the estimate is near. These guys have got wonderful calculators also. Amazon and Google, Rackspace, all these cloud providers give you calculators where you can key in your needs, your demands, or basically your RAM, compute power, storage, and bandwidth consumption. You just key in and they'll tell you how much you'll actually be anticipating, what are the costs you're looking at. So with that, when you utilize it, your meter starts running, you compare it and see, and do that cross-checking. So make sure you do this meter and billing at least first time. Once you understand it well, you trust them, that's it. Then you can just leave it up to them. Keep a tab on your cloud meter. The meters just keep running up and down. Just keep moving up. So you have to be careful that you don't cross that specific threshold. There are also models where you can actually tap that and tell them that, okay, fine, it goes beyond this, please inform me. So that's always there, the cloud management tools which these vendors provide. Data transfer costs. Make sure the transfers are internal to the provider. This is a very, a very silly thing which we do. We just move data around here and there, but make sure data external to the provider is charged. Internal to the provider is not charged. Like, for example, you move data from Amazon one zone to another zone within that region, so they don't charge you anything. But if you move it out of Amazon, say, to your data center, or move it to, say, some other cloud provider, they charge you data transfer rates. So be aware of it. They say it's free. So what is free is the internal is free. Internal transfers are free, not the external transfers. Latency. Watch out for low latency requirements. Understand performance requirements. So latency, if you have desktop applications, typical like executables running which are requiring microseconds of delay response times back, watch out for them. Don't simply move to the cloud. So cloud does have a little latency issue because remember one thing, it's virtualization. So it's available on the web there. So there will be little latency issues. There are companies which are working with latency issues and they provide, there are solutions for it. It's not that there are no solutions, but make sure you know what is your latency requirement and you have the equivalent solution available. So not all the cloud providers provide you with all the solutions. So you have to be careful and choose them. The next is the state. Check cloud providers' persistence. That is very important actually. This was one of the issues we got into first. So simple example, Amazon is not persistent. You just load up an instance, the initial link, and you store some data on it. You shut down the instance, the data is lost. It's not persistent. But for example, you take cloud providers which are based on VMware or based on Hyper-V hypervisors, they are persistent. So I open up a box in OpSource, for example. They are VMware based. I store some data on the OpSource cloud, say for example the file on the desktop, and I shut it down. That file is available by default. But on the Amazon, it's not available. You have to do some use some techniques to actually save that data. So be careful of that. So you need watch out for that persistence. So just you load a cloud, load an instance up, you put all your data there. You just don't think that it works like a normal system. You just shut it down and everything goes off. I mean, everything is available when you shut it back. I mean, you start it back again. So be aware of it. So they're basically best practices. You need to take care. All solutions are available. We just need to do it the right way. Data regulations. Check where data is stored. Data laws are different in each country. This was something which is new, which came up even in the Cloud Expo too. Many vendors are talking about data. When you're storing data in one country to another country, there's a lot of issues going on. So the laws are different. So you be sure that your data, where you're going to store your data, the cloud provider has a specific data center there, a specific zone there. So so that you can store your data there and freely there without any issues. Okay, so what is it that DSL offers as cloud professional services? Before we go to the case studies, I just wanted to talk about what we do basically. So we have strategy workshops. We study and review existing businesses, give an IT strategy, recommend future alignment of both with cloud computing services. So we conduct workshops, educate our customer, educate the user, how we can use cloud computing, whether it's really useful for them, and give them a strategy how to migrate to the cloud. So that's what we do as one of our services. Readiness assessments, inventory, review and assess current IT applications, policies, resources, and check readiness for migration to the cloud. So what it means is we check up all your infrastructure. First of all, we see what you have, what can be moved to the cloud. Remember, not all cases are cloud compliant. So you just can't say, I want to take a printer and I want to move it to the cloud. It doesn't work like that. So what we do is we come back, we have a readiness assessment done. We have a lot of questionnaires which we fill up, which we ask the customer to fill up. Our team comes down, we come into the company and we do an analysis of that. And then we say what infrastructure can be moved to the cloud, how much you'll be saving moving to the cloud. We'll give you all that ROI. Everything will be given to you. So that's one of our next service, the consulting. We consult services to build, operate, and manage private and hybrid cloud. So you know cloud computing suits your needs. You want to basically build it now. So yes, we do that. We can come and build you a private cloud or a hybrid cloud. We have done it for multiple clients of ours. So we use VMware, we use Ubuntu Enterprise Cloud, the Red Hat Cloud, the Cloud Stack, which is Cloud.com Stack, and Eucalyptus is another cloud. A private cloud provider. So we are familiar with all of them. So we can come and build you a private cloud and configure everything for you and provide you as a consulting service also. But we maintain the infrastructure and the cloud platforms as well. Migration of traditional applications to the cloud. This is one of our major needs we come across. Most of our clients and prospects are looking in this specific space. They're looking in legacy modernization, integrating into public clouds, with in-house apps, basically moving applications from the traditional data center into the cloud for scalability. And there are various reasons why they do that, for scalability and availability and a whole bunch of reasons like that. So they give us the reasons, we study that application, and we actually take that application right from the data center and move it onto the cloud. So that's one of our services what we provide. And we integrate on the cloud, integrate their application back to the data center if any connections are required, if that application communicates with third-party applications or some specific applications within the IT organization. So we take care of all those connections and give them a solution, a whole full solution. Support services, supporting, managing, and administering customers' infrastructure and applications on the cloud. This is a part of the support services, cloud-based managed services, managed support services, where we after putting everything on the cloud, somebody has to maintain it, right? The instances, the systems, the applications, and patch updates, and antivirus updates, and a whole bunch of things, what you traditionally do in a data center. So we take care of that too as well. So cloud services, smart price cloud services, we do business continuity. We have one of our services, business continuity. We do backup and disaster recovery and business continuity services. So we have different levels like silver, gold, and platinum levels of organizations. So anything, basically we all know what is backup and what is disaster recovery. So I don't want to have to explain in detail this, but we do offer these one of our services. So Smart Price Data Center as a service. Basically, ZSL will build your next data center in the cloud and will provide support management and administration to run it for you. That's the new thing which is coming up, and VMware is also pushing this very forward, and we are partners of VMware as well. So we can provide you an entire data center in the cloud. So basically, we'll have it as in Amazon or some public cloud which you need. We can create an entire data center with all your systems, everything, and give it to you. Or you can build a data center on your own infrastructure itself. So it depends on how you want it. Smart Price Development and Testing Cloud. This is something picking up again, and we offer this service. We can create a development and testing environment that scales up and scales down and in and out according to demand. Performance, security, automated testing, everything can be done. So we can simulate all this and create a cloud for you, bring it down and you don't need it. So cloud partnerships, we have partnered with all these cloud. This is a little bit old, I believe. There are some more partners which we have partnered with. Major ones being Amazon, Red Hat, Windows Azure, Opsos, and Google, and RightScale, and Rackspace also is there. Yeah. So all of them we partner with any of the cloud providers. With all of them, yeah. With IBM Cloud also, we're doing a lot of stuff with them. So industry recognition, I want to quickly skip. 130 cloud bars that get it right. That's one of the recognition we got. We got top 250 in the Information Week, and SOCNet, which is our solution, which won the NDTC's Mid-Atlantic Technology Innovation Award. And PowerCube Dash is recognized in IBM Lotus Awards. And there's so many list of awards. We just mentioned a few of them. So we are doing something on the cloud. So I just wanted to mention this. So the cloud case studies, I wanted to go through it quickly. So use cases, case studies. Yeah, there was a kind of a question I had. I didn't know how to put a use case in a case study. For me, all these basically came up as use cases first. And then they turned out to be projects, and it was funded, and then it turned out to be become a case study at the end of the day. So let's go to the first one. Is SOCNet on Amazon and UEC. SOCNet is basically a knowledge management and collaboration solution powered by IBM, SPSS Smash, Java, MySQL. So we deployed SOCNet first on a data center. We had scalability issues. So the typical use case was application scalability. So we couldn't scale it up. We had performance issues, network issues, a lot of other things came up. So when we put it on the cloud and used the cloud infrastructure, we had 350% increase in performance. So you can imagine how much of difference we saw in that. So what basically this means is we put the entire solution on the cloud. We have users and clients. So users are basically the web users, and the clients are basically the administrators, or the guys who manage the entire application. So they connect with the VPN, or they can connect with HTTP and basically maintain this whole site. It was very comfortable, very easy. We didn't have to maintain infrastructure. It was very simple, and we saved a lot of our time and money. So we developed this SOCNet and put it on the private and the public. So it works on both clouds. It works with Amazon. It works with Ubuntu Enterprise Cloud, with any practical cloud provider. We've tested it on Amazon's cloud, OpSource's cloud, in the private clouds, Ubuntu Enterprise Cloud, and the Eucalyptus, that is Eucalyptus, and Cloud.com also. So it works on all these clouds. It should work with the others also. The case study 2, basically the use case was application availability reduced infrastructure costs. This was the main reason they moved to the cloud. So they had some security. We all talk about cloud security being very less. Yeah, it was very less, but we actually secured this specific, with this customer. They've got like millions of transactions going on the cloud. So we used the Amazon cloud service for this. They had some kind of identity theft and fraud prevention products which they wanted to host. So it was a desktop application. We hosted it on the cloud. We created a VPN. We had two-way communication security and key-based security, and helped them out. So they are comfortable with that, and they're running perfectly well. And their basic issue was availability and reduced infrastructure costs, because you didn't want to maintain infrastructure into the company, because if you maintain it, you have to take care of security and all sorts of issues like that. So this was done. Then JBoss clustering in UEC for a financial institution. Their main issue was scalability, as you see, clustering. So we created this specific proof of concept on the Ubuntu Enterprise Cloud, where you could scale JBoss. Everybody knows JBoss is an application server and Tomcat in the open source world. So I can go much detail into this, but it's not required at this stage. But the basic use case here was application scalability. How do you scale dynamically and in the cloud, in a private cloud? And that's what we demonstrated in this whole exercise. So we are able to scale JBoss dynamically, and the worker nodes just start up. They go get added to the cluster, and you don't have to worry about it. And as they get added to the cluster, and then when the load increases, when the load decreases, we have a system where we can disconnect them from the cluster and shut the instances down. So each of these nodes are basically running instances in the cloud. So we demonstrated this whole concept. So this was one very good use case, and they liked it, and they actually went, gone ahead and we are implementing the solution for them. Case study 4, basically application migration for a leading radio service provider. He came up and said, I have 15 plus applications, very huge applications. 15 doesn't mean they're small applications, but they are pretty huge applications which are running on more than around 50 or 100 nodes, clustered 100 nodes. So he wanted to run this whole thing, the whole service. So he had the same issues, application migration, scalability, and the reduced infrastructure costs. So this was one of the major concerns they had. So we helped them out. We migrated the entire application and we scaled it up and showed it to him, and he's very happy with that right now. So, and he also had business continuity and DR, which we also provided him with that. So his customer's pretty comfortable. This is the leading media service provider, the case study 5. Again, application scalability, growing infrastructure demand and availability. We used Amazon's cloud extensively in this case. It's something like YouTube, similar to YouTube. They wanted an entire media service on the web, but it's a little different from YouTube. This is a little bit more in detail and powerful, a little bit more powerful than YouTube. So it required a lot of performance on the server. It also required a lot of streaming capabilities. So there were a whole bunch of things which they required. So a traditional data center, we had to do a lot of things to do this. So it would have been very expensive too. We leveraged Amazon's cloud, and we used the S3 service for storage, EC2 for computing, load balancing, auto scaling, service CDN. We use the CDN CloudFront for monitoring CloudWatch, for emailing, simple email service. So SQS for the queuing portion of it. Route 53 for DNS management. So all the services, at least around 8 or 10 services of Amazon we used. So currently they have got more than around 200 clients, I believe, with like more than 10,000 videos streaming online. So it's a pretty big guy. So we did this whole solution for the Amazon cloud. But by the way, we built it such a way that it works with other clouds. Because of our experience, we built it. We didn't do a vendor lock-in. You can actually take the same service and run it on any other cloud with few minimum tweaks, a few minimum changes. We can run it on any other cloud. So it's not glued onto that specific cloud provider. So this is basically just a screenshot of that application which runs. It's live right now, so it's running and streaming very well using Flash and Plex, all the technologies we use here. So SmartPrice Storefront is one of our stores we do where we buy and sell. We sell our products online. So this again, we use a 15-node cluster to actually service this need of the growing demands and elasticity. So we scaled in and scaled out as it says. So it runs on Windows and Windows Azure also. Some portions of it run on Windows Azure and some of them on Amazon. So basically that's what I'm saying. Certain clouds are good at certain things, certain specific features. We need to go and find out what the right cloud is, or probably a combination of them would do the job for you. So that's what we did here. So that's just a screenshot of that. So apart from all this, we also have like the SmartPrice Business Intelligence Suite and Mobile Suite. They're cloud enabled. They're running on IBM Cloud and the Amazon's Cloud. So we also have like the mobile CRM thing also running on the cloud. So we can keep on continuing, like you say, like a lot of other solutions which we have built. But just for the lack of time, I just want to make sure that we finish on time. That's it. That's from my side. But I'll give it over to Sugalya so that she can continue from there.
The session is open. You can post your questions on the chat window, the right hand side of your screen. So we got in a question posted. The question is, you mentioned about scaling up and scaling down, both scaling in and scaling out. Can you elaborate on this?
Okay, yeah. I did mention about scaling out and scaling in and scaling up and scaling down. Yeah, that's a good question. Actually, many people use these terms in different ways. But this is what the basically scaling in and scaling out and scaling up and scaling down mean. Scaling up means when you increase, you have a server, an instance, and you increase the server's capacity. So example, I have a 4 gig machine running with say 4 processors, and I want to scale up. So I increase that to 8 gigs of memory, and I increase it to 8 processors, for example. So that is scaling up. Now, why I mentioned this is many cloud providers have the scaling up. Some of them, like for example, the Amazon's cloud, when you say scaling up, when you scale up, you have to move to the next, you have to upgrade your instance. I can't go and say, if I have 2 GB machine, I want it at 3 GB or 4 GB. I cannot do that. I have to go to the next available upgrade. I have to upgrade the instance. So that is Amazon, how Amazon does it. If you go to off-source or any other cloud provider, many of the cloud providers, you can actually go and say from 7 GB, or so I pay for 4 GB, I can make it 5 GB, 6 GB, 7 GB, I can go per GB. So I only pay for that specific 1 GB extra what I add. So scaling up and scaling down is within the same server. Scaling out and scaling in, like I have one server, I want to add 2 more servers to it and add a cluster. That is scaling out. So I have an identical server of say 4 GB RAM and 4 GB 4 processors. I want to have another server there which has got the same identical configuration, and the third one and fourth one, and I want all of them to work as a cluster. That is scaling out. Scaling in is bringing it down again. So I have 5 or 10 servers, and I bring it down to again 2 servers, and the load is less. So I hope that answers the question.
Okay, thanks, Naveen. The other question is, you did mention about hypervisor. So what is it?
Yeah, actually, I mentioned it in the middle. Yeah, it's also a nice question. It's basically a concept of virtualization. I mentioned about Hyper-V too. I think that's what it was. Hyper-V and VMware. So all this cloud, it runs under a virtualization backbone. So every cloud provider uses virtualization, and virtualization is nothing but using a hypervisor. The hypervisor is actually the software piece of software which runs, which emulates all these resources to you via the cloud. So there are multiple hypervisors available. The popular ones, the first one, the one commercial available ones, VMware. So VMware's ESX, ESXi, those are the hypervisors available from VMware. So they are the commercially available ones. We also have hypervisors from like Zen. Zen is an open source hypervisor. It's para-virtualization. And we also have KVM, which is built onto the Linux kernel. So that's also another kind of hypervisor. So the another one hypervisor building up right now from the Microsoft platform is the Hyper-V hypervisor. So there are different hypervisors. So all these cloud providers, when you go to them, you can actually ask them what hypervisor they run under. So you have that. When they say they run under a specific hypervisor, you can gauge certain points as to whether it's really useful for you. But of course, the IT team or somebody will help you out, or the vendor will help you out, or people like us can help you out, which kind of cloud is required. So I hope that answers the hypervisor question.
Okay, any other questions? Let's wait one more minute to see if any questions are coming in. So we have a question. So does the hypervisor place the OLS in cloud?
What is the question?
So can you, I think this question is from Peter Boyd. So can you, okay. So does a hypervisor plays a role in cloud?
Yes. The hypervisor definitely plays a role in the cloud. As I said, every cloud platform is built on virtualization, and virtualization definitely uses a hypervisor. I'll tell you. For example, the Amazon uses Zen-based hypervisor. Off-source cloud uses the VMware-based hypervisor. Rackspace, I believe, uses Zen-based again, or KVM-based. Ubuntu Enterprise Cloud uses KVM-based. Red Hat uses KVM-based hypervisors. So the hypervisor definitely plays a role in the cloud. Every cloud provider runs on hypervisors. So it's first virtualization. Let's understand this. A hypervisor over that is virtualization, over that is the cloud. So it does play a role, definitely, yes.
So any questions? Okay. For any additional questions, you can email us anytime at info@zslinc.com, or you can call us at 732-549-9770. So I would like to thank everyone for joining us on today's webinar. This webinar will be posted on ZSL's TV and webinar page. Thank you. Have a great day.
Thank you.